Okay, we'll get started in shit. We'll get started in just a minute. We had the wrong room on the agenda for a little while, so we're just going to give people an extra minute or two to get over here, just in case they didn't realize. Okay, let's go ahead and get started. This is the HTTP working group. I am one of your chairs, Mark Dunningham. Our other chair is remote. Tommy, are you with us? Ah, there's Tommy.
Oh, I've been working on my floating head vibe.
You're doing well. You're doing well.
Thank you. Thank you.
Happy Friday. So let's go ahead and get into it. I hope by this point in the week you're familiar with this. It is the Note Well. This is the terms and conditions under which we participate in IETF work regarding things like intellectual property, code of conduct, privacy, and so forth. It is important we do take it seriously. So if you're not familiar with this, please do take a look at it. You can find it using your favorite internet search engine with the phrase IETF Note Well. Just a reminder, again, I hope by this point in the week everybody's aware, we do have a mask policy for this meeting. If you are not speaking to microphone or eating or drinking, please keep a mask on and please do those things minimally. You generally don't need to take your mask off to talk at the mic, for example. Can we have a volunteer for scribing? What? Who? Any volunteers? Thank you very much. So the link for the notes is in the top of the agenda. It's also on the agenda page for data tracker. You can go in there and edit those, and if folks would help out with the minuting, that would be much appreciated. So our agenda for today. That was Monday. Today we have done this bit. First up is resumable uploads for about 25 minutes. It's a relatively new draft for us. Then the retrofit draft, and then the query draft. And then we'll go from our active drafts to the other topics. David Skenazy already presented unprompted auth on, it was so long ago, on Monday, therefore allowing himself to sleep in this morning. Congratulations, David, on your strategy there. We'll talk about origin, so we'll skip to origin deployment, then talk about modern HTTP proxies from Ben Schwartz, and then finally, finally HTTP authentication with Sazzle. So we very well may not use the entire slot. We shall see. Any agenda bashing? Okay, let's go ahead and go into it. I'm going to attempt to use the use preloaded slides tool, although I should stop sharing my screen. Can folks see this? I would say can remote folks see it, but we're same things remote here effectively. Yeah. Take it away.
Thank you. Hello and good morning. Is that talking distance fine? Is that okay? Perfect. Welcome to last day of IETF. I'm going to talk a bit about resumable uploads. My name is Marius Kleidl, and we've been working on this fairly recently only. Next slide, please. Right. Before I want to get started with these major issues, I want to do two things briefly. We have been working on a small example implementation of this in the last couple of days. I've been told the IETF is about running code, so we provide running code. Maybe Jonathan could paste the link to it in the chat. So if you want to check it out, feel free to do so. It's a small server implementation using Go, and it demonstrates a few of the things that we've been thinking about, and it's more intended as a proof of concept. But if you want to take a look at it, feel free to and leave a few comments. Other than that, I would like to get started with a relatively brief overview of how resumable uploads are currently intended to work, so we all are on the same page about that. You know, in HTTP, we have resumable downloads for quite some time, but not really a way to do resumable uploads in a standardized way. Every vendor implements it on their own way, but they're mostly conceptually always the same. You have in the beginning an upload creation procedure or something where the client tells the server, hey, I want to do resumable file uploads. And after that, you have additional requests which actually transfer the data. In our case, we call that the upload appending procedure, because an upload is basically an appending file that you only push data to, but never write at different offsets. There's also the offset retrieving procedure. So whenever the upload connection gets interrupted or the user pauses and you want to restart the upload, or not restart, but resume the upload, you want to know how much data the server has received. So you can use the upload, the offset retrieving procedure to query the server, hey, how much data do you have? What else do I have to send you? And that's basically the flow of resumable uploads, how we've been currently written it down in the draft. However, there's still a few major issues that have to be discussed. These are mainly these four. There are a few more others, but I think these are the most important ones. And if we can get some feedback or some agreement about these, that would be a really great outcome. I think I want to go through these individually, present them on a slide, and then if there's some feedback, we can discuss it directly before moving to the next issue. So please, next slide. The first one is the most major one. It's about server-generated URLs versus client-generated token. The question at hand here is, how do we identify the uploads? What approach do we use? The current draft uses client-generated tokens. That means the client, it generates a token on the client side, and then includes this token in every request that it sends to the server regarding this upload. We currently use the upload token header for that, and that offers a few benefits, namely that you can always retry the request because the client always has the ID of the upload, so it can always associate it with that. But on the other hand, it of course breaks a bit with the standard procedures that we have in HTTP. The server is not able to influence this ID. It only has to take care of the upload token that is given. So there's been valid criticism of this approach of these upload tokens, and therefore we have a proposal at hand to use server-generated upload URLs. The way that this is different is that the client, during the upload creation procedure, says to the server, hey, I want to do resumable uploads. Please give me a URL where I can push my data to. And that's basically what the server does. So the server responds with the upload URL in two ways. It can send it using a 1xx informational response. That's really great to send it to the client as soon as possible. And it also includes it in a 2xx response. Because the thing is that in the upload creation procedure, it would also be great if you already could include some data to minimize the amount of round trips that you have to do. The thing with server-generated URLs is that if we use another element, the item potency key, which I'm going to talk about on the next slide, we can achieve pretty much the same results as with the client-generated upload token. Namely, we have a lot of retriability, and we can upload small files in a single request. That's only a brief overview of this entire discussion. And now this is kind of the question to the audience. What do we prefer? Do we want to use client-generated upload tokens? Do we want to use server-generated URLs? Maybe both. So that's the point where any feedback is welcome.
Any response from the working group? Oh, I see Kazuho.
First, I actually have a question regarding this slide. It says server-generated URL versus client-generated tokens. If I recall correctly, the original title was between server-generated tokens versus client-generated tokens. So did it change? I mean, did the discussion change recently?
You mean about server-generated tokens?
Right. So if I recall correctly, I mean, so is the discussion now between specifically about server-generated tokens being embedded in the URL rather than a header field or somewhere else versus client-generated tokens? Or
yeah, the idea would be that the server generates a URL, and that would encode some kind of token.
I see. So it's all right. Thank you very much. So I think my comment regarding this discussion in general would be that I prefer server-generated tokens because with client-generated tokens, there are issues like conflicts, for example. And regarding how we embed the server-generated token, I think there has to be a discussion between whether it should be part of the URL. I mean, like a RESTful model where you create a temporary URL to which you push data and then commit, versus you sending the ID in the request header field, and thereby doing it below the RESTful layer. So I think there's a philosophical discussion in there. I don't have a strong opinion. I mean, either can be implemented. So I hope that there will be clarification regarding that point as well.
Okay. Yeah. Thanks, Kazuho. Jonathan.
Hi, Jonathan Flatt, Apple. Thanks, Marius, for the great work in this, and it's really exciting to see. I was originally on team client-generated token for the reason of being able to send all of the data on the first HTTP request and being able to easily fall back if the server doesn't support it. But I think I see that there's great benefit in still using these server-generated URLs as long as we have those 1xx responses to kind of convey support. And so I definitely support this implementation with the server-generated URLs. I also think it's a little bit more like HTTP getting that like location URL and then using that as provided by the server to contact it again if you need to resume. So overall, I support. Thanks.
Thank you.
Ted.
Ted Hardy, thanks for the work. It's interesting, and I think this is a useful question. I was a little confused, though, about how this would interact in your mind with things like e-tags. Because it turns out that if you're creating new URLs, you're in essence minting new e-tag spaces. And when I was looking at this and trying to model in my head how the fetch portion of this, if you're fetching an offset to after an upload was going to work, whether you intended to use those at all. Because if you do, then I think I prefer the server generated upload URLs. But if you're not, then I think the client generated token is equally good and I don't have an opinion. So I wondered how you were modeling those, especially in relation to this and to the idempotency keys.
Is it about e-tags?
Yes.
Okay, so to be honest, we haven't considered e-tags that much yet. I think that e-tags, yeah, I don't think I can provide an answer for that yet.
Okay, so let me just say then that if you do the server generated upload URLs, every time you do one of these fetches to see whether the client and the server have the same sense of the offset, if you use e-tags at all, you're generating a new e-tag space because it's a new URL. I think you might want to keep that in mind as you consider this.
Maybe just if I understood it correctly, the server generated URL won't change during the upload. So even if you make a request to retrieve the offset, the URL would still stay the same.
Ted Hardy again. If you never change the upload URLs in the course of this, you do simplify things, but I think you actually lose some of the power of that approach.
Okay. Yeah, let's talk about this later. Thank you.
Martin.
Martin Thompson, I was just going to get up to say +1 to all the other people. I think Kazuho's point about whether this is just a token or a URL is fine, pertinent. But in thinking about Ted's question, I think I probably lean more towards the URL. That's kind of how we identify things in HTTP. And maybe I can help with Ted's question. I don't know if this is the right way of thinking about this one, but when you make an initial request to do an upload, you do that to a particular resource, and you may have some intent with respect to that resource, and there may be some semantics associated with that one. For instance, if you're doing a put on that resource and you're effectively looking to replace the existing representation with a new, obviously large thing, the content of that resource is ultimately going to change once the entire process is done. Until that process is done, it's probably not going to change. And you essentially have a transaction that's outstanding. And what you're doing by providing this upload URL is identifying with a URL the transaction that you're conducting with respect to the original resource. It is a little different when you're talking about a resource that accepts posts or something like that, and you're trying to provide. We can put you in queue, Ted. Don't
Yeah,
bother.
that's
You're
fine.
fine.
Let us not stand on ceremony here.
Yeah. It's a little different when you're talking about a post where essentially you are always sort of creating a transaction that may not necessarily change the state of the resource. It may just do some other things related to it. It may create other resources. For instance, if you're thinking about the case where you post to a resource in order to create another resource. And so I think when you map all of these things out, the ultimate effect of all of these is simply that you just have a new resource that's tracking the transaction, and that's the thing that you're going to interact with when you're talking about how far am I through the upload, how much what data do you have, how do I add extra things when I come back to it later on. And I think to Ted's questions about e-tags, that resource potentially has it has some implications for e-tags, but I don't think that we're looking to really provide all of the sort of caching semantics on that resource, other than just to say that it's a thing that has this upload offset state.
Ted Hardy, apologies for not being in the queue. That was very helpful, but I think one of the things I've been wondering about with this is, obviously I'm also involved in MOQ, is how this would interact with the kinds of resources where somebody is posting to a resource in order to populate it, and other people begin having access to that resource before the first resource is complete. And obviously for certain kinds of media, that's going to be a big thing, right? And so that's partly why I'm thinking about whether or not you're going to change URLs and whether or not those URLs have specific entity tags in that context. So I think for your replacement thing, I'm totally on board with exactly what you said. Yeah. But for posting resources, especially that don't have a defined completion at the beginning of the posting, you may find that there's a little bit more power if you take the other approach and do give them sort of an entity tag view of it, because then the person posting can know what the other clients have access to at that point. Does that make sense?
Yeah, so I get where you're coming from, Ted. I think this is a really interesting question, but I don't think it's fundamentally any different to the scenario where you have a resource that's changing currently. So there's a lot of, for instance, live TV streaming scenarios where you use something like HLS or Dash to access a resource that is usually sort of framed as, I have a sort of a manifest resource that tells me about little chunks of information that I can get, and that continuously updates. There, the structure of the system is what is you have the main resource, which is essentially continuously changing, which contains this manifest, and the caching semantics on that one are essentially just busted. You don't cache that thing. The chunks that you're pulling down each have their own identity and e-tags and caching semantics and can be pulled down independently, although that does potentially change in some of the live broadcast scenarios where you talk about resizing chunks and all sorts of other things. So I don't think we're inventing a new problem here. I think we're just sort of in the space where the existing problems that we have with respect to resources that change continuously like this are a little bit awkward anyway. So, Jonathan.
Jonathan.
Hi, Jonathan Flack. I think something that isn't mentioned here and may be mentioned as like a minor thing towards the end of the slides, if I remember correctly, is the potential for intermittent 1xx responses, kind of like something that a client may get over time, sort of like a progress indicator. And I was wondering if anyone had considerations on that, maybe even for this purpose of e-tags or being able to demarcate those resources as they're being uploaded if other clients are accessing them. Thanks.
Great, thanks. And I got onto Q just to, I think I've brought this up before, but we should remember that, you know, if we're trying to create a generic facility for HTTP, we don't necessarily have to choose one here. We could do both. And you know, it's very easy to fall into the thinking that, oh, we want, you know, high interoperability, so we just should specify one way to do it. But you know, it is also, HTTP is a very generic protocol, and so we should accommodate lots of different kind of use cases. And if we find that there are valid use cases that require both patterns, that's something we should consider, I think, personally. Hans.
So this is Hans-Jörg Habel, file migration enthusiast. I very much like this kind of proposal, so I think that's something really needed. I try to think a little bit and seek a little bit in my information if I would have a preference on this. Probably my gut feeling would also be for server-generated URLs. I found one scenario in which probably client-generated URLs would be helpful, which is sort of, I found, ruled out in the proposal, which is parallel uploads. So there might be scenarios in which you have multiple clients that won't be able to receive the ID given by a server. So I wanted to ask that later, but maybe it fits in here now, why parallel uploads are ruled out then.
Parallel uploads is a really good thing, a good point. The draft currently does not consider them, to keep it a bit more like simple for the first thing. Parallel uploads, we have been experimenting with them in production, and people are kind of split about them. Some say, yeah, it's good. Some say it's not that good. So for now, we have decided to like keep it out, but it's a really good point. If people are interested in doing parallel uploads to utilize more bandwidth or upload from different machines, then that is definitely something to be considered. But right now, it's not yet included.
Thanks.
Martin, and then we should probably
we'll move on to the next one.
Yeah.
I was just going to say parallel uploads is kind of orthogonal to this question. If you do something like this, you can potentially support parallel uploads, maybe not immediately, but certainly after a round trip, which I don't think is a particular problem if you're talking about the need to upload in parallel at high volume. So I think we'll probably talk about that in another context. It's more the status check that gets complicated when you're doing parallel uploads, because now you have multiple chunks at different offsets with gaps in between each.
So it sounds like there's support for server generated, maybe a little more discussion on list, and then
Definitely. Yeah, thank you all for that feedback already. Let's go to the next slide. So this, another issue that we have is that the upload creation procedure is not idempotent, meaning if the client does not receive the response for the upload creation procedure, and, okay, maybe I'll be back. Assuming we go with server generated URLs. With client tokens, this would be a bit different issue. The problem is if the client does not receive the response for the upload creation procedure, it doesn't have an upload URL. It doesn't have an upload token. So it doesn't know what to do next, where do I resume this upload? Now, in theory, we could say, okay, just retry the request. But that causes problem because that might result in duplicate upload resources on the server. And depending on your business logic, this is something that you might want to avoid, where you say, I have one user and this user only has a limited amount of upload resources. So there's this draft for the idempotency key header in the HTTP API working group, and will be a really great fit to put onto the upload creation procedure. Basically, that way you get retryable upload creation procedures. And even if the client is not able to receive the response, it can just send the same request again with the same idempotency key and receive the same upload URL, and then basically go with the entire dance of uploading, appending, and offset retrieving as well. Of course, this is only doable if the client knows the server supports it, because not every server supports idempotency key. But it would be a really great fit because in that way, the upload procedure is not only resumable, but it's also retryable from every state. So even if the first response even failed, we can still retry and circumvent these errors. So that's the question. Is this a thing people would like to use? Are there some questions about this, especially since idempotency key is not yet a published draft, I think? Yeah, is there any feedback regarding that point?
Martin?
So there's always a risk when you take a dependency on something that's in this state. I think perhaps this might just be orthogonal, and we can simply say at best that there's a sort of an informative reference saying, oh, by the way, if you want to do this sort of thing, this exists. The challenge with idempotency key is there's multiple challenges with them. It's a little bit difficult for a server to guarantee that they can respect them in all scenarios. And it's kind of difficult for the client to know that the server will use them if the client provides one of them. So I'm sort of leaning towards, at best, a sort of nod towards the draft saying that you do this. We don't need to solve everything in the space of upload with this draft.
Jonathan.
Jonathan Flatt. I think that item potency key is not necessarily needed. It feels a little bit like just like standardizing like a server and a client generated side. But if you, and you need to know that the server supports item potency key anyways. And so I think maybe a better route to go would be to standardize some way of, if you know that a server does support it, then you can just take this extra round trip to get that response anyways. I think there was some discussion about doing that with the upload and complete header. And then you can continue from there. You could do that for like potentially large files if you know that the server supports it. And so I think that +1 to Martin, the item potency key could maybe be an add-on, but not necessarily an integral part of the protocol.
Kazuho?
So regarding the previous issue, if I understand correctly, people, well, at least some people favored server-generated URLs because there's no worry about conflicts in the tokens and those things. Am I correct to understand that this proposal essentially introduces the client-generated token again?
It is very similar in that regard. However, there's the difference that the item potency key would only be used for the upload creation procedure. The upload token would be used for all other requests as well, offset retrieving and upload appending. That does not apply to the item potency key. It would only be used for upload creation.
So let's say client A open a new connection using item potency key XXX. Then another client opens it with XXX. Do they map to the same upload request?
So that's a really great point. The item potency key spec talks a little bit about this, and they say that the server, I think it can, so in theory, yes, they would map to the same resource, and there will be a collision. You can also imagine if you have like, in the context of a request, every request is associated with a user, and then you can have like a separate space of item potency keys for every user. I think the server would have some room to decide how to implement this, but in theory, it's a really good point that item potency keys can collide, yes.
Thank you very much. So to me, it sounds like it has the same problem with client-generated token proposal that we have. So I think I'd prefer not having this. Thank you.
Thank you.
And I got on the queue just to say personally, I think I agree with what Martin was saying, with the proviso that I suspect that the item potency key spec is hopefully going to be done before this spec is going to be done. So I'm not too worried about the dependency there. But stepping back, this is a little similar to the last issue in that we have a choice. Maybe it's a stylistic choice, but it's also kind of a philosophical choice of, are we defining a generic function for use across HTTP, and we point out how we combine it with other HTTP mechanisms, or are we defining a very thin, tightly bound together profile of how those mechanisms interact? And generally, HTTP extensions like this hopefully are more the former, where you can pick and choose them and combine them in interesting ways. So that's something to think about at least.
Thank you. Yeah, that's a really good point. The entire item potency key is optional anyway, both on the server as client side. So we can also leave it out of the draft for now. And if we see later that it's actually useful in production, we can still talk about adding it back. So yeah, thank you very much for that feedback. Let's go to the next slide, please. So the next slide is a relatively easy thing, I would say. Assuming, again, we go with the server-generated URLs, how would the server know that a request is the upload creation procedure? How would it identify that the client is interested in resumable uploads? There's a few options there. We can always slap on a header that's specific to resumable uploads, saying that this is required in the upload creation procedure, and that way the server can identify that the client is interested in resumable uploads. This issue arises because the endpoint for creating resumable uploads may not only serve resumable uploads. It may also be used for uploading non-resumable files. So there has been this idea of using the prefer header for that. The client would include the prefer header in the upload creation procedure. For example, prefer resumable upload. And then the server sees this and it's like, oh, hey, the client wants to do resumable uploads. I'm gonna create an upload resource for it. The prefer header has a kind of nice semantic because the client prefers it. If the server doesn't support it, it's no big deal. It will just fall back to standard uploads. So now here's the question. Is this a good way to identify resumable uploads? Are there other ways? We've been thinking about using expect header, but that's probably off the table because it's kind of complicated. So yeah, any feedback on the prefer header?
Hans.
So, Hans-Jörg Habo. I wonder at which point of time the client should submit that. So intuitively, I would say this is rather something that comes from a server initially in header or something. And what I also would see on top probably, so this is maybe a related but different topic, is the question for which uploads actually this should kick in. So from which size would you prefer to do so? Because typically what we see in APIs, you have non-resumable endpoint or non-resumable upload functions. And you have that resumable upload here, which comes with a considerable overhead in terms of establishing and finishing it. And it might also have performance considerations on the back end, because the back end might handle it differently to commit the final upload and so on. So there's typically a sweet spot to be identified from where to switch for smaller file uploads and larger file uploads. So that might also be interesting from the server, for instance, to indicate to the client what is the preferred size to use which method.
Yeah, maybe to respond to that, it's a really great question. Like I would say from our interest, there's side to make resumable uploads in theory work for all file sizes. That's my point of view. Of course, the great thing about the prefer header that way is basically the server can decide if the client would also indicate somehow the file size, the server could decide, okay, this file is too small. I don't want to create a resumable upload for this. Or the file is big enough. Yeah, I will respond with an upload URL, and then the client uses that one. So with the prefer header, the server could actually decide if it is worth to create an upload resource, because that's a really good point. There are concerns that doing resumable uploads for small files creates too much overhead on the server side.
Yeah, so I see a general topic here and probably overarching this particular point in terms of client and server agreeing upon what makes sense in a given situation.
Thank you.
Jonathan Lett. Yeah, overall, I think the prefer header is good and probably necessary just to, from the client side, if the server sends a 104 regardless or something and a client doesn't support it, that could probably cause issues. I think Hans does bring up a really interesting point about kind of the server deciding whether or not to support it in terms of overhead. When we're starting to adopt this, though, I wonder if that kind of might slow down adoption in terms of if a server is rejecting requests when a client does indeed support it. And so it could be kind of like drawing this line. And I think Marius has a good point that we might want all files to just try to do this immediately. I think there's a little bit of thought that needs to go into whether or not we want to do that.
Thank you. So speaking personally and very strictly just addressing how do you spell this on the wire, I kind of prefer is loosely specified. It's a bit fluffy. It's not really clear what it's for, and there's not a lot of mechanism there. It tends to be used for things that are kind of configured or used by the user. And so I'm a little concerned there might be conflict, even though in theory it won't, but in practice it might. my gut feeling is that we're defining kind of a proper protocol extension here, and so giving it its own header would probably be cleaner and clearer. But that's just a kind of a gut feeling. It's not a anything more than that. Brun.
Bron Gondwana, large file enthusiast. There's a similar pattern in IMAP, and we had the literal, which you can either send a message, send something straight away as a literal, or you can do literal plus, which, sorry, you can say, I want to send a literal item of this size, and the server says yes or no, or you can, literal plus was, you can say, I'm just streaming it to you right now. And there's a new spec that came out a couple of years ago, literal minus, which is if it's less than 4,096 bytes, just send it. If it's greater, then ask permission first. I think something similar, that's something small enough that it's going to fit in a reasonable number of packets. You say, just stream it. But the other side of this is saying to the server, I'm about to send you 100 gigabytes, and the server says, no thanks, I don't want that straight away, rather than the server has this stream coming at it and has to drop the connection because there's no other way to tell you to go away. I think setting a reasonable size and saying anything smaller than this you can send, anything larger you need to ask permission is a good pattern generally. And that's probably the way to do it, which doesn't quite answer this question. But
Still very relevant though.
Jonathan.
I would note though that having like this boundary between large and small file sizes can be a little difficult, especially because every client's case is different in terms of connection speed. And so for one client, losing 10 megabytes of data and having to retry that might be even worse than another client losing 100 megabytes of data if their connection is much faster.
Okay. I'm going to close the queue in just a second. Hans?
So yeah, this is Hans-Jörg once again. So Bron's remark actually made me think that the overall question of what maximum file size will the server accept is also something I'm not aware of is currently specified to be retrievable by the client in any RC or standardized way, and it would probably be super related to this one as well, to include maybe in considerations.
Yes, that's a very good point. Okay, thank you for all of the feedback on that. Let's try to go to the next slide so we don't hold up everything else. Right, this issue is about the expect header. In the upload creation procedure, the server can send an informational response. Right now we use the 104 for that, but that might change. And the question is, because the client can also include data in the upload creation procedure, it might happen, and if the client sends an expect 100 continue, is there a conflict with the two informational responses that we have? Assuming that the server generates server responds with 100 continue, and then later might respond with 104 resumption supported. Personally, I don't really know how the entire expect header is implemented, and if that would cause some complications because it's kind of a special thing. So is there any feedback on that?
So expect continue is still used, perhaps unfortunately. Not a lot though, and you can send more than one informational response or non-final response before you send the final response. So strictly speaking, that should be okay. How it actually interoperates with live software will be really interesting to find out.
That's great. Okay, if there's no concerns regarding that, then let's go please to the last slide. Right, so we talked about the 4 issues that are here in a bit bolder font. Thank you all for that feedback already. There are a few other open issues, which are, I would call a bit more minor. There's one issue about we have these head responses, but they always change because the upload offset changes, and that makes them kind of not cacheable. And there has been a concern voiced on the mailing list that this is not really the idea of a head response because it should be cacheable. So yeah, that's a concern. There's also the proposal that, or the idea that was also voiced from Jonathan Flatt just a minute ago, that the server can regularly send information of responses to let the client know how much data it has received. That's really interesting because that way the server can remove data from its buffer. If it knows the server has stored this information safely and securely, then the client can remove it from its buffer again. And the last two issues are a bit more vague. In theory, there's this idea that using resumable uploads, we can also pause uploads to give priority to other uploads. It's just an idea. If might not even make a mention in a draft, but it's like an idea that could be explored. And the last one is a bit more interesting in if it's possible to integrate resumable uploads into standard HTML forms. So for example, that you can use multi-part uploads with resumable uploads, and that would natively work without interventions from the developers. Just a few ideas. If there's any feedback on that as well, would be really helpful. Otherwise, I'm not sure how much time we have left for discussion.
We should probably move on, I think, yeah, unless people have specific feedback.
Yeah.
Anyone? Hans.
Hans here, Hubble. So one thing that came to my mind that might be very handy in this context is hashes to be returned after the upload. Is that something you considered, you're likely to consider?
Returning what?
A hash of the file as it has been received by the server.
Might be interesting, yes. So previously we have also been working on resumable uploads outside of the IETF, in like a separate project. It's open source. And we have defined something like that as well to like use checksums to ensure the integrity of uploads. People want to use that, but it has not been considered yet here because it's kind of a bit more like a broader scope and we want to keep the draft smaller. But it's a really good point that maybe if the server wants to, that it can also return checksums to let the client know that the file has been uploaded correctly.
Yeah, just as you said, it's very helpful for validation, and there's from the proprietary APIs, there's a lot where you can get it or you have to retrieve an extra code to do it. But yeah, it would be really helpful in that case.
Thank you.
Okay. I think we're done. Thank you very much.
Yeah, thank you for the feedback. We'll try to incorporate it as best as we can. Thank you.
Great. Okay, let's go ahead and move on. Next up is retrofit structured fields. Let's see. Okay. So can folks see that? It's going to get bigger. There it goes. So we have just 4 issues open on this spec. The date definition in retrofit, hopefully people have seen by now, we have a 0.0 of the retrofit, of the structured fields BIS document out now, as of I think yesterday. And the 0.1 of that will take the date type out of the retrofit draft and into that BIS specification. So now we can close this issue once that's done. And that leaves us just with these 3 issues here. One of them I think is almost editorial issue from Martin regarding how we specify the caveats around how to fix up retrofit to make retrofit backporting more successful. We did have a discussion about whether we wanted to actually put those caveats or those modifications into the structured fields parsing algorithms, and I think we landed on not doing so. But I wanted to double check that. So the idea is, for example, when you're parsing around the semicolon that separates some of the elements, you know, if you structured fields parsing doesn't allow white space, but if you allow white space, you get a higher success rate when you're doing backported structured fields. And so the question is, should we modify the structured fields algorithms or add a flag to say I want to be in compatibility mode, for example? And I think the sense was that we probably don't. We probably want to keep those modifications in the retrofit document. Any comments? Julian. Julian?
Yeah, so I actually looked at this ticket this morning, and I think the current text that essentially says you need to pre-process the field value before sticking it into the structured fields parser is kind of crazy, sorry, because it essentially means that people will have to apply some heuristics to transform the field value into something that the parser will accept. And that seems like a very dangerous operation to me, because to do it properly, you would have to parse the field correctly, right? You can't just apply a regex or something like that to a field value to produce something that the structured field parser will take. So I think if we land with that solution, we better do not retrofit at all, because that's really, really risky. So I would absolutely prefer for the common cases like quoted string and white space and so on to actually have a parameterized structured field parser, which has a strict mode, which is the same as before, and that actually incorporates these transformations into the core parsing algorithm. And I think that's what Martin proposed as well.
Okay. So I think that this issue, the proposal is to define in the style of structured fields parsing, after effectively, as they say, monkey patch it. So, after step 3, do this, then continue processing, so forth and so on. That would be one way to do this. So keep it in retrofit. The other would be to actually change the parsing algorithm in structured fields BIS. So do you have a preference about where that ends up?
I believe it should be in the structured fields spec, because we actually want the implementations of structured fields to be consistent. And there's also the slightly orthogonal question whether, if we realize that, for instance, quoted strings are common, that quote characters that are not quotable in structured fields, then maybe I know that opens a new dimension for the structured fields revision, but maybe we should think about actually opening up the string syntax in structured fields to actually be compatible with HTTP quoted strings instead of trying to work around them.
I think it's Martin next.
So Mark, can you talk a bit more about the rationale behind just limiting this to the retrofit draft? Are we just talking about a targeted little bit of extra compatibility for the selected fields that you have in that draft? Is that really what you're trying to do?
I think that's the goal. I think that personally, I would be concerned if we just modified the structured fields parsing algorithms for all structured fields parsing. I think that would, although I can't foresee anything immediate, I can't help but wonder if it would cause some compatibility issues, even though structured fields is relatively new. What I think we would do to mitigate that is to have effectively a mode flag for the parsing algorithm to say, are you in compatible mode or not? And the retrofit draft would say, use a structured fields parser in compatible mode, whereas normally it would not be.
Yeah. I won't do it. There was a joke.
Later.
I think that's probably preferable from my perspective as well. I don't know whether I see this as, here's the structured fields algorithm and here's the modified structured fields algorithm that you would invoke in this case,
right?
Which is essentially what you're trying to do by keeping it in the retrofit document, or sort of folding them in together.
Right.
This is one of the key questions that we have on the revision of the structured fields document, I think, at this point. At some level, I think this is just an editorial choice.
In a way, yeah.
Because you don't want to complicate things too much for someone who's doing the retrofit but you also don't want to complicate things too much for the people who are only doing structured fields and now have to deal with this optionality, and the algorithm gets more complicated. It's trade-offs in both directions. I really don't mind either way.
The algorithm's already pretty complicated, though. So
it's not that complicated to read that document through.
I've heard other feedback to the contrary.
Yeah.
Yeah.
All right. Well,
personally, my concern is if we leave it in retrofit, that we're effectively we may have to duplicate some of the algorithms wholesale to specify the modifications, or make a really ugly go to step 3, do this, and that's just an awful reader experience.
Then that's entirely dependent on the structured fields definition remaining stable as well. So all of these have problems. I think I might be leaning towards Julian's suggestion here, which is to define it in the structured fields document that we currently have open on the table. So
with a flag.
With a flag that you say, unless otherwise specified, do not turn this on.
Okay.
And
I'm okay with that. Yeah. I think that's fine. Okay. Mike Bishop.
Mike Bishop. So if you think about who's going to use these, if you have somebody who's trying to parse a legacy header using a structured field library that they do not themselves control, unless the person who wrote the library knew to add the flag, it won't be there. I think the odds of that happening get a lot better if the structured field spec says you need to have this flag in your parser. And then somebody who wants to apply that parser to a header in a more generic implementation, they just set the flag. Otherwise, they have to go in and start messing with the implementation of step 3, which they do not really, and they didn't really sign up to work on that library.
So it sounds like you're agreeing.
Yes.
Okay. The next one, I noted that there are some differences, or it was pointed out to me, and I'm sorry, I forget who pointed this out to me. There's some differences in error handling between how we specify things in HTTP versus in HTTP parsing versus structured field, for example. When there are multiple instances of the same value in a list header, some list headers specify, I forget, first one wins, and I think we specify last one wins, or vice versa in structured fields. So we just need to point that out as a potential difference. And finally, Chris and a few other people actually have added that we should add some mapped fields for authorization and www authenticate, which I think is a reasonable thing, because people seem to be interested in specifying new authentication schemes these days. So I don't think that's controversial, I hope. Any other feedback on this spec? Okay. Let's move on then to query. Julian. Anything to say about query?
So there is no news on the actual content of the spec. I was kind of limited for several reasons over the last few months, and now that I had some time doing IETF work, I actually had to look at all the other specs in the working group. But that said, I actually looked at the open issues today. So my gut feeling is that we have several areas where we have open tickets for, like improving documentation of motivation and how to deploy that, how to decide whether to use query instead of get, explaining the differences. So these are mainly editorial things. Then there's the discussion about, should we actually specify how a get query with a form-based query string can be transformed into a query, which I think Mark had that idea that we should actually have that example, in which case we actually should go into defining the semantics of that media type for query. So whatever this ugly form-based media type thing for post is called. I keep forgetting this long name. So we probably should, if we say that a media type for a query payload needs a definition what it means for query, then we should actually define that for query. And then we have several open issues about redirections, conditional queries, and caching. So all of these probably could be dealt with by saying, no, we don't do that, or by spending lots of time trying to get these things right. So it depends a bit on the energy that we have for going into these issues. I mean, in theory, we could publish a very small spec that doesn't talk about these things, but then we would lose some of the benefits of actually defining this. So depending on how much energy we have, it's little work remaining and a lot of work remaining. And I'd like to see people volunteering to actually help us nailing these things down.
That sounds good. Any comment or feedback on this spec? I think it may be just a matter of finding the right time or waiting for the right time when people do have some bandwidth to work on this. I know there are a lot of people still interested in it.
Yeah, so my feeling is that we need to get the two digest related specs out so that we can, those need our attention to get to last call and get published. And once they are out, I think for this working group, the main open issues would be then structured fields revision and resumable uploads and this thing. And then we should have more bandwidth for that.
That sounds reasonable to me. Ben Schwartz.
Hi, Ben Schwartz. I'm very naive about this topic. Could you just explain, if you could, why item potency key is not sufficient? When we started this work, I don't think we didn't have item potency key. At least that's my recollection.
Sorry, Ben, are you asking about the query method?
Yes. My question is, if we have post with item potency key, do we still need query?
Julian, do you want to address that?
I agree that there's some overlap here, but query is not only about making things idempotent, but also about making things safe. And just because the client says, just because we have a new mechanism to make a request repeatable doesn't make that request safe, right?
Sure. Could you give me an example of a situation where that would matter to presumably to a party that isn't already part of the conversation, doesn't understand the application layer semantics?
I actually have to think about that.
Okay. Thank you.
It's a good question.
Okay. Well, thank you, Julian. So let's go ahead and move on. We're skipping unprompted auth as discussed. So next up, origin deployment. Sudheesh?
Hello.
Hello.
I hope you can hear me.
Indeed. Let me just get.
Would it be possible for you to share the slides, please?
I'm trying to. 1 second. Let's see. There you go.
Cool. Thank you, Mark. Okay, I'll get started. Hi, everyone. I'm Sudheesh, a PhD student at the University of Washington. And on behalf of all my co-authors at Cloudflare, where I interned over the spring and the summer, I'm presenting some of this work based on the experiments and experiences in deploying origin frames and trying to experiment with connection coalescing. Next slide, please. So what is connection coalescing? And most of you here might already be aware. It is the ability for the clients to reuse an existing underlying connection to retrieve any additional resources, and in the process, prevent the creation of any new connections. So let's try and understand this with this example here. And due to domain sharding techniques that are used by developers and web administrators, which are still remnants of the old HTTP1 protocol, used to trick browsers to create multiple TCP connections, we find that to load the example.com webpage, it is dependent in this example on 3 other domain sharded sub-resources. 2 of these belong to the same domain, while 1 belongs to an external CDN. And this configuration is quite common in today's web pages, but it is interesting because the client, which is the browser in this case, it creates multiple potentially blocking DNS queries to the resolver and ends up in the best case with the IP addresses matching and the connection then being reused. So next slide. But yeah, if we look deeper, it looks like this. The client makes a query for example.com, and the resolver returns a set of IP addresses for the clients to use. The client chooses one of the IP addresses and creates a TCP connection followed by a TLS connection to establish a secure channel, and then retrieves the HTML content of the web page with an HTTP request. Great. So what happens next? And the browser now understands the various sub-resource dependencies that are needed, and it creates the necessary DNS queries. This is where things get interesting. Next slide, please. So the behavior that you see today actually changes based on which client you're using. Chrome, for example, makes the query for CDN.js in this case, and receives the 2 IP addresses, IPB and IPC, in the response from the resolver. And since there was no active connection open to IPB, which could have been there from the first set of DNS responses, it actually creates a new connection and retrieves the required content. Next slide, please. But Firefox, on the other hand, reuses the underlying connection if the IP addresses have a transitive relationship between them. So here in this case, it reuses the existing connection between to IPA to retrieve the content from the sub-resource because IP A, B, and C are transitively related to each other. Next question. Next slide, please. Yeah. So with this understanding in place, we established our research questions, and we set out to understand how much of the internet today is coalescible, where are these sub-resources typically located, and how are they really distributed. And these represent the missed opportunities that we have today, and what changes can we do to address these opportunities, and what would those even look like? So next slide. So we began our measurements by taking the most popular 500,000 Tranco domains, which is a popular ranking list of the top 1,000,000 domains, and we took 500,000 of those. And we successfully navigated to around 315,000 of them. And for each of these navigations, we extracted the request timelines, and this helped us understand where most of the sub-resources were located. And we find that over 14% of the websites depend on sub-resources, which are served from servers that are located in at least one different autonomous system than their own. And 6% of the websites today currently rely fully on the sub-resources, which are also served from the same autonomous system. But another interesting part is that more than 50% of the web pages that we browse to need resources from no more than 6 different autonomous systems to obtain the necessary information and render the web page. So next slide, please. So now that we have an idea of the distribution of these sub-resources, we wanted to understand where these resources were located. So a lot of these websites rely on sub-resources obtained from Google, Cloudflare, and Amazon. And the top 10 autonomous systems which you see in this table are responsible for over 60% of the total requests for sub-resources that we see in our measurement scan. So building on top of the previous work that was published in SIGCOMM by Marwan Fayed and collaborators, we approximate that the potential for connection reuse to the number of unique autonomous systems is the number of unique autonomous systems that we contact. And these results show us that today's connection coalescing opportunities exist because of CDNs. Next slide, please. So this brings us to an interesting standard at the IETF called the HTTP origin frame, which was initially proposed by Nottingham and Nygren from Akamai. And despite the standardization of the origin frames in 2018 as RFC 8336, it has not yet been heavily adopted in the internet ecosystem today. And this could be because of a few challenges posed by origin frames. For example, the default origin frame allows servers sending the HTTP frames to contain any arbitrary host name without authoritativeness. And at the client side, very few clients even support origin frames. And from our observations so far, Firefox is the only client which has a support for origin frames. But because of the issues with authoritativeness in the contents of the frame, the client continues to incur an additional DNS query, which could have been prevented. And next slide, please. But these challenges and the extra potentially blocking DNS queries could be removed by establishing some authority on the origin frames. And it's really, really important to understand that coalescing here not just allows the reuse of the underlying TCP connection over which multiple TLS handshakes could be made, but instead pushes the reuse to its limit by combining the TCP and TLS connection reuse. So here in the request 5, you see that the HTTP request without the TLS connections, which you saw before. Next slide, please. So once a connection is established by the client to the server sends a hint to the client telling which additional host names it is authoritative for, and it serves a modified certificate. I think we probably skipped the slide. Can we go back one? Yeah.
Oh.
Sorry. Yeah. Yeah, so this is where I was. I think I didn't see the little dots before. Yeah, when the new connection is established and the server sends a hint to the client telling which additional host names it is authoritative for, and it serves this modified certificate, which it is possible for server operators, maintainers, or the CDNs to actually change the certificates and include additional DNS SAN extension, SAN names into the DNS SAN extension of the TLS certificate. So in the next slide, please. So knowing this information, we go back and look at the scans that we ran and model the impact of using origin frames. And to do this, we combined the various resources from the same autonomous system and carefully truncated the DNS and TLS connection times wherever possible, recreating a new rendered timeline of events. So let's talk about the example you see here. For a website, example.com, which is served by the CDN network, also serving cdnhost.com, you see on the top, the second and third requests results into DNS queries and TLS connections being established. But the fourth request for static.example.com is blocked until the third one is actually complete. In the case where an origin frame is sent, the example.com stream 0 would also include the information for assets.cdnhost.com and static.example.com. And this would prevent the additional DNS and TLS connections and reuse them to retrieve the resources. So the client bottlenecks, such as the wait time or block time, continue to remain, and the timeline is moved ahead. By by reconstructing these, our model says that deploying origin frames could reduce the median number of DNS and TLS connections by over 60%, which is shown with the arrow pointing to the green line on the left. And compared to the restricted IP address-based coalescing mechanisms that is in the blue line, and our actual measurement, which is in the red lines. So the theoretical modeling kind of implies that the page load time for the websites might also get faster because of the smaller timelines. Next slide, please. So at Cloudflare, we ran some large-scale experiments for both IP and origin frame-based coalescing. For the IP-based coalescing, we configured and coordinated our DNS resolvers and the serving infrastructure to respond to clients with the same IP addresses for each of the sub-resources that are served by Cloudflare. And this allows clients to reuse connections to the same IP. But performing such coordination between the DNS and the serving infrastructure is particularly challenging because of the various traffic engineering rules and service level guarantees the CDN networks might have for their customers. And next slide, please. So
oh, my browser seems to have, hold on.
well, I see there's a question, but I can probably field that. It looks like Jonathan is already on it, but I see Martin's question, which is, does the modeling consider the effect of the congestion control window on the transfer of sub-resources? It actually does not, at least in the way we did the modeling. It was kind of naive, and we wanted to see what the overall possibility might look like. But I'm happy to take more questions later. Yeah, thank you, Mark. So where was I? Yes, yeah. So I mean, overall, the deployment of origin frames kind of gives us some advantages, and this is there is no longer this need to coordinate between the DNS and the services and the serving infrastructure itself, and the CDN can perform its own traffic engineering practices without any disruptions. But with authoritative changes, it allowed clients. It allows these clients to prevent additional DNS queries. But we also found that approximately 92% of the websites that we had in our measurement need less than 10 additions to their certificates to achieve this effectiveness. Next slide, please. So overall, the usage of origin frames makes coalescing practical while posing relatively lesser additional overheads on the network operators. And it reduces the additional communication costs at the clients and has little difference to the wireline activities that happen. So to validate our results, we sampled 5,000 websites proxied by Cloudflare's infrastructure, split them up into a control and experimental group, and deployed origin frames for the experiment group with modifications to the certificates. And our goal was to attempt coalesce the connections from the websites to CDN.js, which they were dependent on. And on the next slide, please. So our results were very interesting. Our results show that connection coalescing with origin frames does work in practice. And overall, in our deployments, we found 50% fewer connections to CDN.js during the experiment, with no changes observed in the control set. And this has a lot of implications. This implies that there is reduced cryptographic verifications needed to verify the certificates by the clients. And the active measurements from clients also indicate that around 65 to 70% of the connections can successfully be coalesced. So another implication is that there is reduced number of connections for the CDN operators, which means fewer sockets being used. And as a result, it allows more clients to connect to the same infrastructure, so which definitely has a set of advantages. Next slide, Mark, please. So a natural question which follows up based on the timelines that I showed before, the modeling, is what happens to performance? And in our modeling, we find that if every operator deployed origin frames efficiently, it could result in an improvement in page load times. But individually, with only Cloudflare making the changes, there is very minor improvement in page load, which we might be able to see. But our active deployments, however, did not see any improvements for both IP or origin-based deployments. But we suspect this could be due to various other path characteristics or bottleneck shares. And maybe it could benefit, and we could rerun these experiments again with more operators who would deploy origin frames. So currently, instead of improved performance or page load time metrics, we conservatively claim that the origin frames makes performance no worse. Next slide, please. So we'd like to stress that the performance actually cannot be assumed to improve, and it should be avoided as the primary motivation for us to do connection coalescing. The other implications, like the reduced server-side resources, the improvements to clients for their cryptographic compute, reduced state maintenance, and lesser burdens on traffic engineering are stronger motivating factors to actually deploy connection coalescing in the world. Next slide, please. So one key challenge we observed, which might explain the lack of adoption of origin frames, is the lack of support for server-side origin frames. And we contribute an implementation of origin frames with our code changes to Golang, and the changes are maintained in the Golang and net module forks that are on the GitHub Cloudflare org. Next slide, please. So interestingly, during our experiments, we realized that the origin frames should be deployed with caution. And there are many non-RFC compliant network stacks deployed out there, which might result into incorrect behavior. So our experiments uncovered uncovered a compliance issue in the network stack from a large antivirus and an internet security software vendor. And the internet security software installed on client devices, it did not discard unknown HTTP frames, as was recommended in the specification, but instead resulted in the teardown of the entire connection. So the clients could not access some of the websites that were in our experimental and that were in our experiments during when we ran these over the 2-week period. Next slide, please. But we really believe that the key motivator for actually deploying origin frames are really the privacy benefits to the ecosystem rather than performance. But this needs additional investigation. But it's very simply put, for each coalesced connection, we hide what would be an otherwise plain text SNI field, and it prevents any plain text DNS queries from being leaked to the network adversaries. Next slide, please. But the most interesting one is resource scheduling, which is really, really exciting. And the usage of origin frames, it moves the scheduling opportunities to the resource endpoints, which are the servers and the clients. And without origin frames, multiple connections compete for the available network capacity. For example, the server sends 2 resources, A and B, which are requested by the client in multiple connections, but the clients might have made the requests in order expecting A followed by B to render the page faster. And these additional connections followed by all the undeterministic path characteristics, it might actually result in the client receiving the sub-resources in a different order, and browsers continue to wait before being able to successfully render this web page. Next slide, please.
Sorry, did it again.
No problem.
Let's see if we can get it back up.
Yeah, thank you. So the usage of origin frames, it allows servers to schedule and prioritize these resources and send higher priority resources, and in the process, it'll be able to provide the necessary resources for the in the order that the clients might actually want them. And this work is really a call to action for other operators and large content providers to deploy origin frames. There are various benefits for the origin frames and maybe clients should also deploy support for the authoritative origin frames, because the servers can only provide the hints and they can't really enable coalescing until the client actually wants to enable coalescing. But this also opens up a lot of exciting opportunities for DNS early hints, certificate frames, and like improved adoption for the prefetch or preload attributes, while also allowing content providers to efficiently perform if they would want HTML rewriting and optimize the delivery of these resources. So next slide. So with that, I'm open to questions.
Great.
Thank you.
Thank you, Sadish. I think Tommy and I had this presentation because it's relevant to not only our past work, but our ongoing work, and it's really good to get these checkpoints to see how the mechanisms we define are going. So if people have questions or comments, please queue up. While folks queue up, I just want to note it's almost 11 a.m. Some of you may realize it is Armistice Day. So this is at 11 o'clock, at least in, I believe, Commonwealth countries, people typically take 1 or 2 minutes of silence to recognize the sacrifices of people beforehand. I don't think we're going to pause proceedings here to do that, but if you want to leave the room, please feel free to do so, and we'll continue with the agenda. Thank you. So Brian.
Brian Call, Yahoo. I had a question. So on your traffic that you simulated, did you do any like browser caching or anything like that? Was it like just clear cache or?
Yeah, so for all the measurements that we ran it with clean profiles with no caching. And the reason was we wanted to actually observe the behavior on the network itself. If browsers cache a lot of resources, we would not really see the need for coalescing. But we wanted to study the impacts of coalescing itself, so we ignored the aspect of caching completely.
Okay. Yeah, I was just wondering if you thought about like doing page reloads or things like that and see how it differs between like cold cache versus a warmer cache.
Yeah, that's definitely a very, very valid question, and I don't really have an answer for that.
Here's
Here's a Hanlon. Just wondering, you didn't really lay out sort of the exact type of where you used H2, H3, congestion control sort of stuff. I guess you're not always necessarily aware of it all, but I wondered what the sort of breakdown was in terms of the different protocols, because that could affect the performance quite a bit. I mean, because if it's just using 1.1 over TLS, then as opposed to say H3 over Quick, could make it quite a big difference when you're maybe trying to put multiple requests down the same pipe.
Yeah, sorry, I really should have made it clearer in the start, but we were focused only on HTTP2.
HTTP2, okay, right.
Yeah.
Fine, yeah. So I guess, I don't know, I guess the performance stuff may come with some of that you don't have so much head of line blocking issues, but then potentially that might be an issue that holds you up. Okay, thanks.
Yeah, thank you. I definitely think there are a lot of interesting places to like study performance a lot more.
Okay, thank you very much, and we encourage more work like this. I think this is great to get this kind of feedback.
Thank you. Thank you for having me.
Okay, next on the agenda, Ben, are you ready with modern HTTP proxies? Go ahead, Ben.
Okay, next slide. So in HTTP 1.1 and even prior, this is what proxies looked like. So this is just a reminder. This is what proxies have looked like for a long time. So for an HTTP request proxy, you use this thing called absolute URI form, where you take the path, the URI that you're trying to fetch, and you put that in the request line. And then in HTTP 1.1, you can have a different host header that that identifies the proxy. And the same sort of arrangement goes in Connect, only this time instead of absolute URI form, it's an extra special request form where the desired resource is replaced by a host : port string. These have some really, I think, unfortunate properties. One is that you can only have one proxy per origin. So unlike everything else in HTTP, which is exists on a path, so you can have more than one on every origin. These proxy services don't have a path of their own. The service is only identified by this host header. But and then even sort of to make it even worse, virtual hosting of these things is essentially impossible. So you can't share multiple proxy origins on a single IP address. You could in HTTP 1.1 using this host header, but starting in HTTP 2, there is no equivalent of absolute URI form. It's only possible to express a single authority for each request. So that means the proxy just has to know what the actual authority of the proxy is. It's not expressed in the request. With TCP transport proxies, so like HTTP Connect, the same problems apply. Plus, I just wanted to note that like if you have a mix of IPv4 and IPv6 addresses, it would be nice to be able to get happy eyeballs from that, from the proxy. But instead, all you can do is pass single IP addresses to the proxy. Next slide. So we have the MASC working group for the past couple years, and the MASC working group had to solve essentially the same problems for UDP and IP proxying, and they dodged all of these problems. They recognized that we have these problems with the old mechanisms, and so they came up with proxy mechanisms so that going forward we don't have this problem. So the way it works is that the proxy services are identified by URI templates, and then the template encodes the host of the target into the URI path of the request. So that makes it entirely possible to have an explicit proxy authority, which is clearly separate from the host that you're trying to reach. Next slide. That's oh.
Ben. He'll be back. Okay.
He should be back shortly. He's had this happen several times this week.
Okay.
Sorry.
There he is. Hi.
So this draft just proposes to take that strategy and use it to create a modern version of these classic HTTP proxy functions. So Connect TCP is the more obvious one, certainly. So it uses extended connect, just like Connect UDP and Connect IP, with a new protocol. It does not use the capsule protocol complicated thing that was invented for Connect UDP and web transport because it isn't needed. And the HTTP request proxy just works exactly like like old-fashioned forward proxies today, except that we define this URI template that contains another URI inside it. Next slide. So this is a specific proposal, and so there are a lot of interesting details about this specific proposal that I'm happy to talk through. But the most important thing I want to get to the working group is, if you were designing HTTP request proxying or HTTP Connect today, how would you do it? And can we write a draft to say, okay, here's how you do it, in the way that we think would really be best today. Next slide. So this is a 0-0 design. It does happen to line up nicely with another draft that I wrote about taking a bunch of different kinds of, like taking the Connect UDP and Connect TCP and DO and putting them all in a nice collection together so you can use them as a unit. And this, I would like to see this draft adopted. There's some charter scoping questions about what could fit in the MASC working group. MASC is rechartering, but it's definitely not clear to me that any of this work would fit in MASC, even after a recharter. That's it.
Okay, so any questions, feedback for Ben? Martin.
Hi, Ben. I think you probably already received this feedback, but I think that there's a number of people who have different levels of comfort with the two different pieces in this draft. I think the TCP Connect thing is something that a lot of people have expressed interest in at various times. And the idea that you might be able to ask a particular resource for a connection to a remote host is an interesting one. The request proxying side of things is far less clear in terms of intent. And I think I'd like to see that split out. That's the one that engages with all the difficult questions about, well, why don't you just put the URL of the target and send that request to the proxy without any need to have an identifier for the proxy? Or why don't you tunnel binary messages? Those sorts of questions are the things that we would have to engage with there. It may be.
Could we go back one slide, please? I just want to point out that that's my last bullet.
Yeah, and I picked that up off your slide. But okay. I think it may actually be the case that we want to do multiples of them to one of Mark's earlier points about things, that the number of ways in which these things can be put together manifold. And so maybe splitting that work out is a little bit more, makes the easy part easier.
Okay, I'd also appreciate your thoughts on where that would go. I could argue for MASC or HTTP-BIS or HTTP API.
I think I would rule out the HTTP API working group for this, but this is something that this group could take on very easily. I think this group could also say MASC is capable of doing it, but I think the decision starts here at this point because the protocol is owned here, and this is really core protocol mechanics.
Okay.
Mike.
Mike Bishop, I would echo a lot of that. I really like the reworking of Connect for TCP. I'm not totally sold on the request proxying. If we do one or both of those, I would not be surprised to see it in MASC, but also from the recharter discussion earlier this week, it does not sound like they want to put that in their scope. And I think it certainly is in scope for this working group. So I would like to see at least the TCP Connect version progress here, and maybe we talk about what the future is of passing the HTTP messages apparently unencrypted. which maybe you just use OHI for that.
So for the OHI, I should say that is my intended use case for this HTTP request proxy functionality. This is somewhat controversial, I guess, within the OHI context, but right now OHI essentially says you need something that looks exactly like an HTTP forward proxy, but we don't specify how you actually use it. That's considered out of scope. So I want to come up with a standard for that. Otherwise, it's essentially by private arrangement.
I'm going to close the queue soon. Eric?
Yeah, some minor points we can debate in the future aside, I think this is a good idea. I like it. I think this is the right working group for it. As I said in the mask working group earlier this week, I think this is general proxy, and the mask group is trying to, or at least I want them to avoid becoming the general proxying working group. The one concern I have before I say, yes, let's adopt this now is, well, I think this is a good idea and I like it. I don't know if it's enough of a good idea for all the legacy proxy implementations to rewrite it onto this new way of doing things. So I'd like to see a little bit more discussion of the use cases, the clients we think will want to implement this, servers that we think will want to implement this. I know you mentioned OHI a minute ago, so maybe there's stuff to do there, but I'd just like to see a little bit more discussion of what we think this will be used for, besides just, hey, everyone rewrite your old stuff, unless we get a bunch of people saying, yes, we're going to rewrite all of our old stuff to use this.
Okay, thanks.
David?
David Skenazy, mask enthusiast. I just want to echo what's been said before. We're over at Google, we're building new privacy proxies, and in the case we're building stuff from scratch, doing the new Connect TCP sounds interesting. We don't have a use case for the other bit though, and as Martin pointed out, there would be dragons, so I would unbundle the two. And then on the question of the working group, I want to echo Eric's point, like the goal of at least as I personally would like to see it, the goal of the new charter of Mask is not to become all of the proxy things place. So HTTPBIS sounds preferable, but I'm not strongly opposed to this happening in Mask. Thanks.
Thanks, David. And so personally, my feedback is I think this is probably fine, but we need to have a discussion about how it's positioned and maybe the terminology that it uses. I highly doubt that people deploying HTTP proxies today and writing HTTP proxies today are going to be enthusiastic about switching over to this just for the sake of it. And so maybe we shouldn't be calling this modern HTTP proxies because it implies that it will replace them. I think it's an alternative for other use cases. But we should have that discussion.
Okay, yeah, that title is going to change.
It's great to be ambitious, but you know. Any other feedback? Actually, I locked the queue, but I think we're done here. Tommy, what do you think? Do we need to take a hum on adoption here, or just take it to the list?
I think at this point, it'd be good to take it to the list. It sounds like we have pretty consistent feedback that there should be a split here, and there's more clear support for the TCP side of things, which I personally agree with as well. So maybe, Ben, if you can provide a renamed, smaller focused document on TCP and maybe split out the message proxying, and then we'll take that to the list.
Okay, will do.
Sounds good. All right. Thank you, Ben. Finally, we've got HTTP Sazalin, and thanks to David Skenazy doing his session on Monday, we're perfectly on time. So let's get going on that one. Take it away.
Yeah, hello. My name is Rick van Rijn. I've had a common cold the last few days, so my throat is a bit sore, so I'm sorry for my voice.
Could you get just a bit close to the microphone?
Yeah.
Might help.
Okay. I wouldn't say I'm as native and as at home at HTTP as you guys are. I fly into protocols from security and from cryptography. In this case, identity is my concern. And I found that HTTP tends to be less flexible in terms of identity management and usage patterns than other protocols. Of course, for browser use cases, that's usually resolved by doing things in HTML and JavaScript. There are also RESTful API use cases where it would be very nice to have stronger and more flexible authentication mechanisms, I think. So next slide, please.
Okay. Just a note, so we have 14 minutes, so keep that in mind if you want discussion at the end.
Yeah, sure. So most protocols stem from a date after HTTP. Of course, HTTP has a very long history and have adopted SASL because it gives them flexibility. The client can choose a mechanism that it can support from list, and it can choose something that matches their desire for cryptographic strength and might even involve things like channel binding, which in general are very difficult to do in HTTP, but in particular use cases might actually be very useful. Also, SASL allows protocols to share knowledge about authentication mechanisms. So not every protocol has to invent it again. And I think HTTP will benefit from having SASL added. Next slide, please. So HTTP authentication appears to be an island. It's defining its own mechanisms. Sometimes inspired by SASL, sometimes in another way. And I think that's just double effort, and it's a pity, especially because there's such a strong focus on the browser for authentication purposes, so that RESTful applications sort of stay behind. And that's a pity, I think. A few examples that I would have liked to see adopted somehow in HTTP and that are very easy to do through SASL would be Kerberos authentication, which is very weak in terms of security. And something new that IETF is doing at this point is opaque. The guy implementing that came up to me, I explained to him how to do this in SASL. He was very happy that we had an implementation for HTTP SASL because that meant he could demonstrate his very cryptographically very advanced mechanism in the protocol that most people favor to see a demo in and to use, of course. So next slide, please. This is just a miscellaneous point that I ran into. When you look, and if I'm wrong, please tell me. As far as I understand, the user in an URI defines an authority, so part of where to locate the resource. And well, we all know that basic authentication has been used a bit outside of the specification. I don't think there's ever been a specification to put a username there. But it seems to have a red auth part in the specification of the URI's authentication part. That I think has caused a lot of confusion about usernames in HTTP up to a point where it's not even used. It's forbidden actually. URIs is a whole domain on its own. I sometimes feel a desire to publish information, publish resources in a way that is not iterable in DNS, because DNS very often can be iterated, even with the DNSSEC. It would be very nice to have a way to conceal like a homepage if you consider it private. And independent of what URIs do, I think it might be very useful to add a user header akin to the host header to do exactly that, where the host will be exactly what it is now, and the user will be further refinement of what we're looking at. Next slide, please. So, well, I mentioned a few of these things already. Quantum computing, of course, is one of those risks that's threatening us. It will be really a pity to not be agile and easily adopt new mechanisms that might help with that. Channel binding is one of these things that you can't put in a spec for HTTP, I think, because there are places where you can't rely on it, simply because people hop in connections all the time. That's part of HTTP. But a client that doesn't do that might actually benefit from such a facility, depending on the application. And well, I mentioned opaque already. There was a guy who really enjoyed having a way to use HTTP with his mechanism. I've also spoken to the web consortium who were working on the sovereign identity mechanism, wanted to use it in all sorts of protocols and preferably also in HTTP. Ran into the obstacle of having to go through IETF to formalize a mechanism there, and was very happy to instead use HTTP SASL. So next slide, please. So this is basically how it looks. The SASL part is not a surprise, of course. The realm is what it always is. The initial 401 or 407 would send a mechanism list, so that's 3 in this case. And that could be a server-to-server token that is basically state that carried from the server to the client and sent back to the server. And this is where this proposal does something that an earlier attempt, I think 10 or 12 years ago, failed because the HTTP authentication framework wasn't defined at that time. But it was already felt improper to store state in the server, which was part of the design back then, because SASL can make a number of iterations and may need to store data from one to the next. So I've resolved that with an extra token server to server that just bounces back and forth with encryption and signature. And on the bottom, you can see a first response by the client where it selects one of the mechanisms and sends a first client to server token. This stuff would all be base 64 encoded, of course. Next slide, please. I covered all that. Next slide, please. Now, this is something advanced, an advanced use case for which we are very much interested in this. And that's to use SASL over HTTP, arrive at a web server, and then continue to a backend using diameter, and actually turn back to the client's own domain where he runs his own identity provider, so that he doesn't need to store an account in every individual web server, but can actually just walk up to a web server, log on with credentials that he himself manages, and then end up being authenticated because the web server is told this is joe@example.com. You can proceed, and you can assume that this is secure identity. And we have this all working. I mean, this is the stuff I love to do about identity and crypto. And again, HTTP SASL will be a driver for making this possible. Next slide, please. So we've implemented this stuff. It's part of Apache. It's part of, well, it's a module for Apache that we designed. It's there's an extension for Nginx. There's a plugin for Firefox does this stuff. And we've been doing part of this work as an NGI pointer project for the European Union because it's also more in line with the GDPR than the few centralized silos that now take control over weblog on basically. So we think it adds something there. There are more slides of this one detailing the blog specifications and code. So go ahead and have a look. I would really like this group to accept the SASL proposal or work on it or whatever. I'm quite willing to help with that, of course, or be active in it. But I'd like your questions and opinions, please.
Thank you. So questions, comments, thoughts about working on SASL and HTTP? Especially in implementer interest is interesting to find out about.
Jonathan Hoyland, Cloudflare. Sorry, I couldn't get the tool to work. Isn't SASL a security thing? And isn't HTTP in the general area? As in, like, shouldn't this be in a security area group?
The answer to that has varied in the past. I wouldn't worry too much about that, but we have worked on authentication schemes in the past. When we do so, we do coordinate with security quite tightly.
Yeah, this will send to you by the dispatch group. So that's why it's here.
So Martin Thompson, I think this is probably the right place to talk about this sort of thing, because I think just using something like Sazzle is fairly straightforward in the sense that you've got messages that are well defined. Maybe we need to learn a few things if we were going to do something like this, but this group can integrate these things, and the integration into HTTP is probably the most interesting part of any work like this. The question about implementer interest is something that I can't really answer at this point. We have no interest in doing this. The question I have, however, that relates to that is, to what extent is it possible through, for instance, browser APIs to simply do this in user space in say a web page?
That's exactly what we've done. In Firefox, it's a web extension that just picks up the header and then processes it, and actually uses a modern extension in browsers that connects to the client desktop to actually process the stuff and keep the credentials outside of the browser.
So does that require, however, privileged access to the contents of requests and responses, or can you simply use the fetch API and add your own header fields to those?
Sorry, I don't understand what you're asking.
So you've built a web extension.
Yeah, no, I didn't build it, somebody else built it.
Okay, someone's built a web extension, yes, okay. Is it possible to build just within a web page, either using service workers or straight up fetch API JavaScript?
That would not work for automation interfaces, for RESTful APIs and that sort of thing.
I understand that. I'm trying to assess whether this is whether the self-service capability is there, because that brings me to the next question is, or suggestion perhaps, is if it is possible to drive one of these things in a self-service fashion, then that gives you an opportunity to demonstrate utility without necessarily requiring everyone in the ecosystem to implement something. Integrating this into browsers, for instance, would be quite a challenge, because we have to do not just the work here, but the work in Fetch and other places in order to get that to work. But if you can just go over the top, demonstrate that it has utility, then you can build momentum for the effort. We can recognize that, and we can perhaps then systematize it in those specifications without having to initially grapple with the deployment and implementer interest questions.
Yeah, and that could be an application that does RESTful things, for example, and then uses it perhaps in a Python fashion or something. Yeah.
Thank you.
Follow up, Alexei Melnikov, Sassel enthusiast. Is access to WW Authenticate and authorization a privileged access that you were talking about?
I believe so.
I'm not certain. I think there's privileged information that browsers will put in those header fields in certain contexts, but I don't know for certain whether or not you can, from say JavaScript, just set the values if you know the values that you want to set in them. So typically when you talk about in the browser context, when you make a credentialed request, which is what Fetch refers to it as, you ask for a credentialed request, and what you're asking for is access to credentials that the browser holds in some store that you don't have access to by ordinary means. You can't simply get the credentials out and use them yourself. You're asking the browser to access its store and put them in there. In those contexts, there's constraints then on what you can see from the Fetch API in terms of the request and ultimately the responses you get back. But I think it may still be possible to set the values explicitly yourself based on values that you as a website know. Now, don't quote me on that because I have to check the spec, and every time I look at that spec, my little brain explodes, and I probably want to ask someone who's more intimate with it.
You know who that person is, and I was just looking, and it involves cores, so yeah, all bets off. And personally, I think browsers are one interesting part to ask. Another is client libraries like curl, for example. Daniel's not here, but that's another obvious place to go. We're at time, but it sounds like this is just a continuing discussion, and I think a continuing discussion. I think Tommy and I will have a chat. We might have some more discussion on lists. Obviously, I don't think this is something that would involve a broad effort in the working group. The question is, would it be productive to have a focused effort to get this as a spec produced, or whether we should wait a bit longer, as Martin seems to be intimating. So, we'll Tommy and I'll have a chat, and we'll be in touch, and we'll figure out next steps. I think. Yeah.
Thank you.
Thank you.
All right.
I think that's all we have, and we're at time. So thank you all very much.
Yeah, it
and
looks like
oh,
Alexi
sorry.
was.
Go ahead, Tommy.
It looks like Alexi was still in queue. If we just had like a.
Alexi was there
He's
and
done.
came and gone.
Okay.
Sorry.
Yeah, perfect.
Anything to add to that, Tommy? While we're still here.
No, I think that I agree with your summary of that. Yeah.
Okay, great.
Good there.
All right. So we'll take those action items and get back to folks and get back to the list, and hopefully we will see folks in Yokohama. Thanks.
Thank you all.
I think that's back with the author. I think we're good there. Yeah. Did you see what?
Yeah, it's not your area. There were a couple of times I was like editing it because you were and then all of a sudden